joined the hackathon in September 2014 here at the Isaac Newton Institute, and had a good time working with many of you at that time and looking at how we could support this effort. I think it's an exciting one, and there's, I think, exciting aspects from the technology perspective of how we can enable the goals of the CAMI project through the computational infrastructure that we can make available. And so, so that time, and I'll sort of go through this in a minute, but at that time we organized some mechanism by which Pittsburgh Supercomputing Center could support the CAMI effort, and so I'd like to talk today about how we can build on that and what we can do to support CAMI's goals in the future. So just very quickly, just an overview of Pittsburgh Supercomputing Center. We've been around for 30 years now, providing high-performance computing resources to U.S. researchers and their international collaborators. And so we've done this by establishing high-performance computing and networking and data resources funded by various agencies in the United States. And in particular, at this time, through the National Science Foundation, there's a project called Exceed, and we make our resources available to U.S. PIs and their international collaborators through this project. So this project Exceed, Exceed stands for Extreme Science and Engineering Discovery Environment, and it does not fund any hardware for these resources, but what it does is it ties together all these different supercomputing centers throughout the United States who already have or who have been funded to supply these resources through other mechanisms. Exceed ties them together and provides a common mechanism by which they can allocate these resources and share them with researchers. There's also a major investment in scientific support for people who want to use these systems. So there's about 40 FTEs funded through Exceed, and this has just been renewed for another 5 years, this project. And so there's about 40 FTEs funded to work directly with research teams to enable what they want to do on these resources. There, I found the pointer. All right. So we're especially interested in engaging new research communities and those who haven't been using these systems for 30 years. Mostly the 30-year group are physicists and others doing simulation science, and data science has, of course, come to the forefront. And we want to enable that and find ways to do things that haven't been done before using these high-performance computing resources. So PSC is a bridge between researchers and developers of software. And so we work with developers and people developing software and applications and software infrastructure and tools to enable what researchers want to do on these systems. And so we've supported very large projects and been able to make the community more aware of these kinds of resources by working with groups that are engaging the community, like the developers of software tools. Everyone goes to the software website to find what they want to do, and so we found it's very effective to engage folks this way, because they go to the website, they find the software, then they are sad because they don't have the computing resources to run the software, and but then we have a little note there. Oh, if you don't have resources, try PSC, and we can help you. So so that's what we want to do. So we have especially specialized in the past in very large memory systems, although and that's true now as well. But this is great for a lot of memory-hungry bioinformatics software, especially for assembly. And so we've done very large-scale metagenome assemblies there on our large shared memory systems, and also large plant genome assemblies like wheat. And then also been able to enable high-throughput large memory for things like transcriptome assembly, where someone wanted to assemble 20 primate transcriptomes, and we did that in a few weeks using large-scale large memory. So for CAMI, as I mentioned, I was here in 2014, and we were organizing the first CAMI challenge. And so at that time, we decided to submit a proposal to exceed, to allocate resources at the Pittsburgh Supercomputing Center to support this challenge. So we submitted this proposal in October 2014, and then January 2015, this allocation was awarded on PSC's Blacklight system. At the time, this was the large memory system we had at that time. And so this allocation was made available, and some CAMI participants actually did use this allocation on PSC's Blacklight to run especially the assemblies, and I think maybe some of the downstream analysis as well. I'm not totally sure about that, but mainly it was focused on supporting the assemblies, which many people didn't have the resources to support on their own infrastructure. But an issue at the time is that this was, at this time, PSC, the Blacklight system was on the verge of retirement, and so it was an older Linux kernel. We didn't have support for things like Docker. So we couldn't support the full pipeline at that time that was being developed for CAMI. But so today I'm going to talk a little bit about our new shiny system here that's been especially developed to support the kind of flexible, data-driven workflows that we're interested in supporting for bioinformatics, and especially potentially for CAMI. And so this bridges system is flexible in a lot of ways. So it's got so this is the hardware infrastructure, and so we continue this tradition of supporting large shared memory resources. We have several 12 terabyte nodes on the system. We'll have eventually dozens of 3 terabyte nodes, and then we'll have hundreds of these more traditional nodes with 128 gigabytes of memory, and then also GPUs and so forth. All this will be tied together with a very fast interconnect. This is the first system to have Intel's new OmniPath networking network, and so that's probably not that exciting to all of you, but for HPC geeks, that's really exciting. And then we'll have petabyte, 10 petabytes or so of project file system to tie this all together. All these nodes will also have local storage, which is great for data-driven workflows, and a lot of times we can use RAM as the file system, which is really nice for accelerating bioinformatics workflows. So now, all of this then is also made available through, we'll have persistent database and web servers, and so people can host their frameworks and provide services and provide an interface to this large-scale infrastructure through whatever interface they want to provide. So, I'm going to show. So some of the things that Bridges will enable is interactive use of these systems. Traditionally, you get on, you submit a batch job, and you wait a while, and then your job runs. You're working on the command line. But we want to support all the possible ways of people interacting with the system. And so there will be opportunities to get sort of immediate interactive access, and also what we call gateways, which is usually some sort of a web interface to the system where people use a browser-based user interface and submit their jobs through that mechanism, maybe coupled with workflow tools like Galaxy, which I'll mention in a moment. And anyone who wants, any developer or group who want to host their framework can do that on these web server nodes. You can get an allocation, and you can just have perpetual presence on Bridges. And then we'll have other types of, so this just shows, we want to support everything. And enable some distributed service-oriented architecture. So you could host it at PSC, or you could have it hosted other places and connect to PSC. There's lots of flexibility. I think is the key thing is flexibility for what people might want to do, and we'll work with people to figure out what that is and how to do it. Also supporting other frameworks for data analysis like Hadoop and Spark, and leveraging the large shared memory and the storage resources that are there, we have a lot of options to support different frameworks for doing data analysis. And also now we'll have strong support for virtual machines and containers, and we're leveraging OpenStack to provision resources on the system between the interactive access, the batch access, like a Hadoop or Spark cluster, or virtual machines. And so there will be, again, flexibility to re-provision the machine according to the needs of researchers. So here's just one example of what I'm talking about. We work with, in the US, there's an initiative, Big Data to Knowledge, and one of the founding awards for that is the Center of Causal Discovery that we collaborate with at the University of Pittsburgh. And so they have a browser-based user interface that people can use to run their causal discovery algorithms. So we have a petabyte of cancer genomic data, the Cancer Genome Atlas, at PSC. And so they'd like to use their algorithms to figure out the causal relationships between genomic features and outcomes of patients. And they've got patient clinical data, and so they want to tie all this together. And so we can host their interface, their web framework on our web nodes and store results in databases hosted there. And then they can interact with the system, run their algorithms on the large memory nodes and regular nodes on bridges, and tie it together with the storage that they need to support that, and like I say, the Cancer Genome Atlas data and so forth. So, so we can support these kind of complex, interesting workflows. People are on an Exceed. In Exceed, we call these science gateways, and there's quite a few of these that are leveraging sites like PSC or San Diego Supercomputer Center, for example, hosts this Cypress Science Gateway. This is very popular. There's many thousands of researchers who use this gateway to do phylogenetic analysis. And so this is an example of something that would be possible for CAMI, would be to have some perpetual presence, either hosted directly on an Exceed resource or on your own servers, but then that sent work to the computational resources on Exceed, in particular, in this case, PSC. So, for example, so we, like I say, so we can host these directly, or they can be hosted remotely. But we have a Galaxy interface running on Bridges right now. Bridges just has gone through its acceptance process. It's very, very new, but people are running there. This is still in. We haven't opened this up fully to users yet, but this is an example of. For something like Trinity and transcriptome assembly and downstream analysis, how you can leverage the flexible architecture of Bridges to do this. So you do the assembly on these very large memory nodes, and then all the downstream analysis just needs a distributed computing without large memory, and so you can send this workflow to the regular memory nodes and come out with an annotated transcriptome there at the end, all through the Galaxy workflow. So something like this might be interesting to explore with CAMI. So just like in terms of general, getting started on Bridges and using, so Bridges is an Exceed resource, and so it's allocated through Exceed, and so anyone can get a starter allocation. Well, you have to be a U.S. PI you have to be in the United States to be a PI on the allocation, but if you have collaborators in the U.S., then they can submit the proposal, and they can add you to their allocation. So we're past this stage with CAMI. This is sort of an easy way to start up. You just write a paragraph, and they say okay, and you go and test your algorithms, test your code on the system, and this lasts for a year. And then once you have an idea of how much you need for your project, then you actually go and write a proposal. And so this is what we did back in October 2014 for CAMI. We wrote a proposal to get a research allocation on Exceed, and these go in quarterly. The next window starts in June 15th for one of these. And you can also request this extended collaborative support service, which means you can get experts from Exceed. I mentioned this major investment in people in Exceed, so you can get people who are experts in building gateways, building these web-based frameworks for running analyses on the infrastructure of Exceed. So we can get other people from PSC and also from other sites to work with us on this without any, just by requesting it through this proposal mechanism. There's no, there's no monetary cost for using the system. It's all just an investment in writing a proposal, and then it's peer reviewed and you get an award. So, okay, there's just that extended collaborative support service I mentioned, which there's support for building science gateways on Exceed. All right, so I want to. This is sort of the proposed, sort of my idea for how we might proceed. So the first thing, if we're going to renew, we would these resource allocations on Exceed systems are renewed yearly. We didn't have to renew the first one we got because we'd used it. We were sort of done with what we needed at the time. So that has lapsed, and so what we can do is we can renew that for whatever we want to do over the next year. And so, one thing we could do would be I think there was some desire to rerun all these analyses anyway. And so a good thing to do would be to rerun everything on bridges, and then we know how much, we get a good estimate for the resource requirements for running these analyses on bridges. And we could feed that into a proposal to renew our allocation on bridges, which we could submit. If we want to jump on it right away, we could submit that in this June-July framework, our time frame. In the meantime, we can look at, again, so we estimate the resource requirements over the next year. What do we think we would need? What kind of things would we do? We can rerun these analyses. We can run other things that may be different from what we've already done, and do some benchmarking, do some tests there. We can also start testing, running the CAMI framework on bridges using deploying Docker on bridges, and also see what kind of needs, what you might like to do in terms of hosting the web interface and how people would interact with this. With the talk we just had about sort of the future of how people would interact with CAMI and submitting their tool and just having it run, and then they get the results in a week. Maybe we can turn it around in a day or something on a big HPC system. So this would be, I think this would be a great way to be able to support this and sustain this in the long term. The gateways like Cypress that I showed you have been running for 6 or 7 years, and they, once you sort of show interest from the community and you start to renew these yearly, then it's basically guaranteed. You'll be able to renew it for the next year, and you just have to justify the resources you're requiring, and you have to develop a plan for how you're going to manage the users who want to come and that sort of thing. So there's some work that needs to go into thinking about that and understanding how we would manage it. But you start out small, and then you can build, and as the community grows, then the resources can grow to support the demand. So this is where I can stop talking, and I'm very interested in hearing feedback and what needs are. I've already talked with Alex and with Peter a bit about how we might proceed. If you have suggestions or ideas for how this might be useful, or if you have questions about how this might be useful, then we can talk now, or we can talk offline, as I'll be here for the next day and a half, and then even a couple extra days after that if anyone's hanging around. So, all right. So that's all I have to say for the moment.
Yeah, I think it's really great that you're involved in providing these services for CAMI developers and participants. Any detailed interaction or any detailed questions?
Yes. So, questions? Yeah.
So you're saying the new system your Docker will run?
Yes.
How did they deal with the security issues?
Well, so the Docker will run, but yes, there are still issues that we have to work out in terms of how do we want to support it and sustain it in the long term. So I think that the answer to that question could be driven by the needs, is going to be driven by the needs of communities. And so so what we need to be able to answer that question is for people to say, this is what we need. And then we figure out a way to support that. And so this would be a great driver for us to, I mean, like I say, Bridges has just been, it's just in production, and we are working with communities like CAMI just to figure out the answer to that question. So, so you tell us what you need to do, and then we figure out, okay, how can we do that in a way that's secure and sustainable and that sort of thing. So, so there certainly are still issues, and there's more than one way that we could potentially implement something like this. And so if we continue the discussion, then we can use this as a driver case to establish this, and then so other people, you may blaze a trail here for others who want to do this sort of thing. But yeah, so that's we'll need to have a discussion and have interactive back and forth to figure out what's the best way to support what you want to do in a way that's secure and effective.
I no fear that someone will mess with our data. I'm rather fearing that one could, for example, use our framework for submitting Dockers. An evil hacker
Right.
submits a Docker that he knows will turn out in your system and then mess with your systems.
Sure. Yeah. Our folks going to be very paranoid about this sort of thing, of course, and so we'll have to make sure that we do it in a way that we can guarantee that people can't get high-level access to the system, that they can't step outside of the bounds. So yeah, it's a shared system. It's a national resource, and so that's always going to be the trade-off. Is that we'll do whatever we can for you as long as it doesn't kill somebody else. So we have this balance that we have to work at. Absolutely.
And it's really great that it will work.
Yeah, but I mean, but in terms of there will be in terms of the just the technological requirements, we can support it, but we do have to figure out the best way to do that doesn't step on other people's toes or introduce security risks, that sort of thing. Yeah.
What would be the typical time limit and number of cores if analysis were to be rerun?
So there's the limit will be defined just by how much we're able to how big our allocation is, basically. We will as a community we'll submit this request for an allocation, and then everyone who wants to use the CAMI allocation will get added to that. And so we'll have to think about how we enforce some sort of fair use there within this community. And so for the first round, we didn't have to worry about that too much. We just kind of said, well, let's see how many people show up, and mostly Alex used all of the allocation. But the other people were able to do what they needed to do. So there's a few people who used it the first time, and it wasn't a big deal. Now, as we get more people using it, then we'll have to have some sort of a internal quota. So that's so that's one of the things that these science gateways have to deal with, is how are we going to enforce per user limits on the system. So there's a function of how much allocation do we have, and then how many people come to use it. Now, some of these gateways have a two-tiered approach. One is that you have a community allocation for people who need sort of modest resources. Modest, again, being defined relative to what your total allocation is. And then other people who have very serious demands for computing resources can actually get their own allocation, and they can still use your framework, but whatever they use gets charged to their own allocation and not to your community pool of resources. So theoretically, I mean, there's no limit. I mean, we have, in terms of, if your allocation is big enough, then you can run on 10,000 cores and whatever RAM and disk, pretty much unlimited. but practically, we're going to have to get some sort of allocation, and then we're going to have to share that amongst the community. And so it'll depend on how well we can justify the resources and how big the allocation is going to be. But yeah, so does that answer your question? Okay.
So it would be good to run these benchmarks again.
Right. Yeah. So then, yeah, we can run some benchmarks. We can get an idea for, how much time does it take to do this unit of work, and then you can see. Then I can tell you that to get an allocation of say a million core hours is sort of a reasonable, between 500,000 to 1 million for someone who's coming in with a second proposal, and they used, they were able to use it successfully the first time around. Then the reviewers sort of look for this, were you able to use it? Was it successful? And then you can start sort of building up, from to 1 million to 2 million to, so you sort of build, year after year, increase the allocation as you show demand and successful use of the system. But yeah, we do need to run those benchmarks to get the estimates. Is there another question?
Yeah, so I might have missed it, but when you apply for one of these allocations, is it free and granted to you, or do you have to pay?
Right. Yeah. So it's free. Yeah. It's already been paid for by taxes, and and so now it's a service to you, but you have to write a proposal, and it gets peer reviewed, and it's all about the computational plan, and it's not generally about the science, especially if there's already funding in place for the science. It's more they're focused on looking at, is this a useful, does this make sense, the plan for how they're going to use the resources? Is it efficient? Have they benchmarked their codes so they know how much time it's going to take? Can they justify that convincingly? And then, yeah, that's right. So all the work is involved in the proposal process, but no actual funds are required.
I'm curious who decides who gets resources. Is it more some academics, or are there more like business people?
No, academic. Yeah, it's it's peer review. Yeah, so so there's an allocation committee that meets every quarter, every 3 months, and from representatives from all fields of science, and so they review and judge, and then the centers have some say in how much they allow on their systems, but subject to the reviewer constraints.
From a technical perspective, are you proposing to host the entire CAMI system, including the web services and everything, on the allocation, basically?
We can do it. So it depends on what you want to do. So we have the technical capability of doing that. That would be one way to do it.
Or is there an easy way to push jobs through the over the internet using an API and retrieve results in one way or the other?
Yes, that's the other way to do it.
Yeah.
So yes, you could do it.
No decision.
That's right. We can decide as we figure out what makes most sense for you, how you'd like to do it. You can even do both. Like you can have a presence. You can have something that talks to each other. But yeah. So there's examples of this. When I showed the Galaxy, so we host this directly, our version of Galaxy, but there's usegalaxy.org, which is the main Galaxy site. They push jobs to us as well. So the large memory jobs get pushed to PSC from the main Galaxy site. And well, they've been testing this. They haven't released this to users yet, but we're close to that being a feature on the main Galaxy site. So anyway, so you can do it both ways. Peter?
Yeah, so one requirement besides Docker is that I need some kind of technology to distribute containers or to queue them somehow on the system. Do you think it would be difficult to install some kind of technology that allows me to distribute containers?
Do you have a technology in mind for that? Or?
Mesos or
Okay. To distribute containers. So I think on these the web server nodes, I think anything you could run on your web server, I think we can run. So I think that shouldn't be a problem.
Okay,
Okay.
but I have to cut you off now, even though it's people seem to be very interested. But so we can because the time is so short that we have. I'm already thinking we should have invited you for one more day maybe, so we get everything done. So thank you again for your presentation.